Okay. Okay. That's pretty good. That's working.
Yeah, please. Very good evening to all of you, and hearty welcome for today's session, which will, of course, be taken by Dr. Owen Green. And let me introduce you to the host of this today's meeting. And we see that this webinar, which is a regular feature on the 22nd of every month, we host this session in which experts from all across the world are invited. And today we are honored that we have among us Dr. Owen Green. This webinar is being organized by Tethys Fossil Museum and Research Center. And this museum, I would say, is coming up at Dhangiari, which is a small village in Kasauli, Tehsil of Indian Himalaya. Geologically, the museum is located on the debris concealing the Dagshai Subathu boundary, which signifies closure of Tethys Sea and evolution of terrestrial ecosystem. The museum has been built from 20-million-year-old rocks of Kasauli Sandstone, beautifully chiseled to give museum an aesthetic look. Water which we drink in the museum is from a borewell drilled into 40 million years old white quartzite sandstone, which is marked by bed extending from Pakistan to Burma in the east. Tethys Museum as such, it will display diverse, well-preserved fossils of Stromatolites, Edia Cara, Trilobites, Molluscs, Ammonites, etc. from Spiti Valley. Fishes, whales, sharks, oysters, molluscan Formanera from Subathu and Leh. Plant remains consisting of logs of... Yes, someone wants to say something? It's fine. So plant remains consisting of logs of trees, leaves, flowers, roots, etc. from Kasauli and Dharamshala, and mammals from Shivaliks, signifying gradual evolution of life on this planet, and all are part of the museum repository. So anyone visiting the museum will have a glimpse of how different fossils collected from different geological formations across the Himalayas can help to rebuild the entire paleohistory, the various events which led to the evolution and birth of the Himalayas. Tethys, as we all know, was an ocean once upon a time separating India from Tibet and Eurasia. As the Indian plate moved northward, the Tethys Sea squeezed, and when the two plates collided, the Tethyan sediments were uplifted, forming the mighty Himalayas. Lots of research has been done in timing the collision, the two plates leading to evolution and birth of the Tethyan Himalayas, but still there is no consensus, and there are Himalayan opportunities for researchers to come up with a convincing model to time the collision and explain the birth of the Himalayas. Keeping this in mind, organizing area is one of the lead researchers here, and the research center, they decided to host a series of lectures by veteran geologists who dedicated their lives to understanding this geomechanism. So today we have among us Dr. Jagmohan Singh, who is a senior geologist, and he will be helping us in proceeding with the program of today. He is working with the ONGC since a long time. He has a lot of contribution as far as research in the field of fossils is concerned. And
thank you, Professor Krishnakant, for your introduction. Can you hear me and see me?
Dr.
Hello.
Owen Green is the speaker for today. He has worked in the Earth Science Department at the University of Oxford since 1989. And for the past 11 years, as manager of the Geofacilities Laboratory, that is Optics Suite, rock preparation labs he has worked with. Prior to moving to Oxford, he was curator of geological collections at Goldsmiths College, University of London. At Oxford, he helped establish the paleobiology laboratories and supported the research of staff, including the late Martin Brazier, who was a micropaleontologist and is co-author on several papers, most notably the contextual studies on the world's oldest 3.5 trillion years old fossils from the archetypal of Western Australia. Other researchers that have worked with Dr. Green, there are immense number of people who have worked with him. He has lots and lots of contribution, and we will be discussing that throughout this today's session. So I welcome Dr. Green for today's session, and this particular format that we are working on, this is being hosted by, of course, Tethys Fossil Museum, which is coming up at Dhangiari, and the museum is built, as I have said, from 20 million year rocks of Kasauli Sandstone, beautifully chiseled to give museum an aesthetic look. And the water in the place, that is Dhangiari, it has been drilled into 40 million year old white quartzite sandstone, which is marker bed extending from Pakistan to Burma. And Tethys Museum has all the kinds of things, that is from Stromatolites to Edia Cara, Trilobites, Molluscs, Ammonites. We have those things there, and students as well as researchers can reach that place and have a look at how these things are coming up. Gradual evolution, life on this planet, and all are part of the museum repository. So anyone visiting the museum will have a glimpse of how different fossils collected from different geological formations, they have come up there. So lots of research has been done in timing the collision of two plates, leading to evolution and birth of Tethys Himalayas. But still there is a lot that can be done in this field, and we would like to hear, of course, the host of the today, Owen Green, sir, who will be giving his lecture on tertiary carbonate platform evolution. And this, of course, is being organized by Tethys Fossil Museum. We welcome you, sir, to today's session, Dr. Owen Green, and we hope that it would be a wonderful session. And of course, along with that, Dr. Singh, you are also there. We would like that you also kindly invite Dr. Owen Green for today's session.
Welcome, Professor Owen Green. I am sure you are comfortable. The lecture possibly has been arranged at a very short notice. So, I feel sorry for that some last minute things only have happened, and we have invited our guests also in last 1 hour only. I hope some of them will be able to join. However, as per practice, the lecture would be available on the Tethys Museum site. So, welcome, Professor Owen Green, for your presentation and enriching us with the knowledge about your experience, lifetime experience. Thank you very much, and welcome for the lecture.
Thank you. Thanks very much, Dr. Singh, and thank you, Krishan and Ritesh as well for inviting me. I'll just share my screen. Okay. Hang on. No, I've got the wrong. I will try and share my screen.
I hope you are comfortable sharing the screen. There is a button in the middle, share.
Yeah.
Just click on that, and after that, you will have to share the file.
It was. Right, so I'm going to do it. Hello. I'm now sharing the entire screen. Right, is it up yet? Can you see?
Doctor, the file that you want to show, kindly take that file on the screen and just click on share screen. That will do.
That's what I've been trying to do. Hello. now. Okay. Still not coming up with what I want. Is that it? Right.
And I think the problem is you have to let Owen share his screen from your computer.
Yeah.
Abodni, if you are there, kindly help Dr. Owen.
No, it's yeah, I think it's you, Krishan. I can't share because I think you're sharing. You've got the
You are the host, Krishan. You have to let Owen Green in to share screen.
Dr. Arya is the host. Just a minute, let me talk to him. Yeah, Amodni, if you are there, kindly, Amodni Arya, kindly help Dr. Owen in sharing his screen, make him the host.
Yes, sir. Sir, I've already made him the host.
Okay, that's fine.
Yes, sir.
so let's try again.
Dr. Owen, just open the file that you want to show on the screen and then click on share.
So yeah, we can already see your shared screen.
You can already see it. Okay.
Yes, sir. Yes, sir.
Yeah,
So
screen
now,
is visible, of course.
whichever. Yes, sir.
Yeah. Let me go to.
So, if it's a presentation, you can just open your presentation and then we can view it.
How's that? You got it?
Yeah, now it's fine, but just open the presentation.
Yes, sir.
This is how we want it. Yes, that's perfect. You just open the presentation, sir.
It's there. Yeah. Okay. So, sorry, we just missed off the title slide there.
Just click on Control F, sir. Control F.
Krishan, we're on your screen. You need to turn off your screen.
Let me just escape this. How's that? Right. Have you got this now? Yeah.
No, it's not. I'm pretty sure the problem is with the host. The host needs to let Owen Green share screen, and then Owen get his slide up and click share screen. But you can only do that when you let him in.
Let's just try that one. All I've got is your screen at the moment, Mike. Hang on, let's see if I can select my. Okay, let's try this again. Right, can you see my screen now, or are you?
No.
No. I was going to say I've got it on. Yeah.
Is your presentation up, Owen?
It is on mine.
Yeah, the problem is with the host. Whoever is hosting the talk needs to let Owen Green in.
Yeah.
You need to let Owen Green share screen, because until you do that, he cannot share screen.
Let me stop.
I think this is the screen of Dr. Owen Green only, and now it is not there. But earlier what we were seeing, that was Dr. Owen's screen only. So you're the host, and I think you have been given the rights by the host for sharing the screen.
Let me
let me talk to Amodini if she can help. Amodini, is it possible on your end to do something? So if Dr. Saab sends his presentation to you, would you be able to share from your end?
Sorry, sir, I got disconnected. If you could just repeat what you just said.
I'm saying that if Dr. Saab, Dr. Green, he
Yes,
sends
sir.
his PPT to you, would you be able
Of
to share from
course.
your end?
Yes, I think I will be able to.
Okay, then, Doctor, if you can, you kindly send it to Dr. Arya's mail from where you had got the invitation.
Let me just.
If it is not happening from your end, I think then it could be possible from the host end.
What are we saying at the moment? Participants can now see your screen. Can you see my screen? Or?
Your screen, of course, is visible, but my name is coming there, Krishan Khan.
Your name is up, yeah. Let's try.
Somehow I am being more prominent somehow.
How about now? If I go to slideshow now.
Yeah, it is. Of course, it is running at the top. I think we can see something, but
Yeah.
on the whole screen, full screen, we are not being able to see.
On the full screen, you're not being able to see it. I don't understand. Gary.
Krishan, are you the host of the talk?
The host is Dr. Arya's daughter, Amodini.
Okay, she needs to let Owen Green into the screen, because until she lets Owen in, he will be unable to show his talk.
Yeah, Amodini, I think you can hear what Mike has said just now, Mike Seri.
Yes, I did.
You need to let him in.
Yeah. I'll try and,
does this work? So if you could just share your screen once, or open the presentation once.
Let me just see. Can you see me now on there? Yeah.
Yes, sir.
Yep. Okay. Let's see if I do that. Right. Can you see that? Are we there?
So did you share your screen?
Yep. Share screen. Let me get my. Participants can now see my screen as the message I've got, so hopefully.
So the problem is with the host. The host needs to let Owen share screen.
You need to let me in.
Sir, if you can open your presentation, it will be shown.
Yep, it's open. And it's going to slideshow. So, right. Yeah?
It's visible to you, sir?
Yeah, have you got that? What are you seeing?
We are seeing you only at two places.
No, this is because the host is not letting Owen share screen. It's not Owen's problem, it is the host problem.
So I can see.
Host, if you can help.
So if you could just guide me, how should I do that? I'm unable to let him in.
The thing is, one thing is that Dr. Owen will be sharing his presentation with you, and you share from your end. I think
I can do that. If he has shared his presentation, I hope I can share my.
Then Dr. Green, you kindly send it to Dr. Arya's email. Is it accessible to you, Amodini?
Let me have a look.
Yes, sir.
Yes. Can you open Dr. Arya's email, or should he send it to some other email?
You can send it on Dr. Arya's email, sir. I'll open it there.
Okay. Dr. Green, you kindly send your presentation to Dr. Arya's email, and Modni will do it from her end.
Okay, let me
Doesn't matter.
see.
So he'll be doing it from there, and then of course you can work on it.
Okay.
Kindly send an email on Dr. Arya's email ID.
Yep. I've got the email up. Hang on, let me just get this, see if the presentation will go on there. Don't know, it's a big file. Will it go on? Yep. Let's see if that works. Okay. Right. Let me send that. I'm about to send something that's 47.
Have you sent the mail, sir?
Yeah.
Modni, kindly check the mail.
Will do, sir. So it's on Tethys Fossil Museum's mail, right?
Yeah.
All right, I'll just check it.
Yeah, it should. It says it's gone. It's gone somewhere.
Yeah, she's doing it. We'll wait for a minute.
Okay. Have you got that?
Modni, could you open it?
Just a minute, sir. I'm looking for it. I have not received it yet.
Can you hear me?
Yes, sir. Not received it, sir.
Says it's gone.
Received, yes, sir. Got it.
Okay.
So it's gone. Yep.
I'll just download it.
Yes. Just download and open from your end.
Will do, sir.
Share it on the screen.
Can you hear me?
Yep.
Yes, sir. We can hear you.
Professor Green, we can see you, but your screen somehow is not coming.
Screen. Modni is sharing the screen, sir. Just a minute.
Since there are technical glitches, can we postpone it for the next opportunity? Oh, yes. Now we can see the screen.
There it is.
Visible, sir?
Yep. Can you put
Perfect.
that on?
Good job. So once again, we welcome Dr. Owen Green.
Can you?
He has lots and lots of research with him that he'll be sharing with us today. Yes, Dr. Owen. And that's.
I was going to say, can you make it
with you now? Kindly.
full screen?
Yeah, full screen. It's visible.
I've not got full screen, but never mind. Okay, I don't think I can. Will I be able to advance the slide or not?
I don't think so, sir. So just let me know. You say next. I'll advance.
Okay.
That will be done by a moment. Yes, kindly.
Yep.
Dr. Owen, kindly start.
Yeah. Okay. Sorry about the technical difficulties on that. Okay, so here's my title. We are constraining the age of the India-Asia collision, and we are using larger benthic foraminifera. So larger benthic foraminifera commonly occur in shallow water, near shore, usually on shelf environments. And the assemblages can be used to define the sort of spatial environments in which they occur and their geographic distribution. And stratigraphically, we hope to constrain that sort of ancient platforms as well. And in particular, as you can see from my title, I want to look at the India-Asia collision. Okay, so the next slide, please. And yeah, keep going. Okay, there should be something else there. Right. Oh, it's gone. Yeah, if you just want to go back to the development. Okay, so carbonate facies variations have been recognized through a number of sort of time periods. And what I want to discuss here is why we use larger benthic foraminifera and their paleo-environmental significance of, within carbonate facies variations. And I'm going to use a modern analog that I've worked on. And then I'm going to sort of take us through the correlating of the tertiary sections that Mike sort of mentioned last week, which are around the Spontang ophiolite. And then we're going to show how we can use these for dating India-Asia plate collision and, of course, the forming of the Himalayas. Okay, next slide, please. So how do we use foraminifera? Well, they're used in a multitude of different sort of aspects now. Clearly, with geochemistry, we can study the shell chemistry, the isotope and trace element, and also now doing a lot of genetic work, particularly on the modern forms that are around. We can also look at their bio and paleogeographic distribution, both globally and regional mapping. Then in biostratigraphy, that's probably where they've been historically used. Taxa can be used for dating strata. And then paleoenvironmentally, they can be used for determining the habitats, either the microhabitats, macrohabitats, and the niches in which they occur. Okay, let's go on to the next slide, please. So carbonate platform development. The facies variations can be recognized through both space and time, and this work is sort of quite well known, superbly illustrated by Wilson in his 1974 book, Carbonate Facies Variation, and various papers as well. That work is absolutely seminal in understanding how facies variations can be applied to carbonate sequences and carbonate lithologies. Then we've got the biostratigraphic zonation. And this is where it becomes a little bit interesting, because with foraminifera, we've got two types that we can actually use. We've got the planktonic free-swimming foraminifera, and there's been lots of work done with them, and I'll refer to that in a little bit in a couple of slides further on. And then we've got the larger benthic foraminifera, of which Lucas Hottinger in the 60s is probably one of the first micropaleontologists to actually really explore how these can be used. And then there's been later work developed on there, which again, I'll sort of make reference to later on. Okay, next slide, please. Right, so first of all, let's deal with the biostratigraphic use of foraminifera, because that's usually applied to things like the planktonics, and in this case I've got an illustration relating to some of the smaller benthics that might be out there. The key thing that we're looking for here is usually the first appearance and the last appearance of when these things occur within the stratigraphy. Once we've sort of determined that, we can often apply a biozonation sort of scheme in their use. So it usually works very, very well with smaller planktonic foraminifera. As we'll see in the next few slides, not so good with the larger benthics. Okay, next slide, please. So here, sorry, this is such a busy diagram, but it does really bring in quite a lot of, what the concepts behind this. So in the white lettering at the top, numbers 1 to 9, these are the carbonate facies zones that were recognized by Wilson. And then the little illustrations of the particular foraminifera, they are showing us going from both shallow water on the left-hand side to deeper water on the right-hand side. The different sort of assemblages that one might expect as one is going down slope into the deeper oceans. And this is all really classic work that was done by people like Orville Bandy and Francis Parker in the sort of the early mid 60s. It's subsequently been developed by Pamela Hallock, working on some of the shallower water assemblages as well. Next slide, please. And so this is the area that I want to sort of mainly concentrate on, because that's where most of the assemblages that I'm looking at come from. And although we have the blow up of the nearshore area from the previous diagram by Berger and et al., I've also included on here another schematic diagram showing you what you might find in some of the carbonate environments. In other words, there's sort of unrimmed shells. There's often a bank restraining some of the sedimentation, and then there's, you know, rimmed shells and things. So there is quite a bit of topography that might be involved in how the shallow basins are developed. All right, let's go on to the next slide, please. Okay, so just a brief resume on what are foraminifera and where do they fit into all the other sort of organisms or groups that we might have come across. So they're single-celled organisms, and they're usually placed within the kingdom of the Protista. And they vary in size from 0.02 millimeters up to 150 millimeters. There can actually be some which are actually larger than that now. In age, they range from the Precambrian right up to the recent. And I've put a little note in here that they might appear to be primitive, but they are certainly not simple. They're actually a very adaptable sort of group of organisms. They usually have a shell, or what we term as a test. There obviously are some naked foraminifera, or the most common one, which most people have heard of, is amoeba. That does not have a shell. It's just a sac of protoplasm. And they are wholly aquatic, and usually that means they are marine. There is some debate as to whether or not some now might sort of range into some of the sort of freshwater type environments, but that's only around things like the where the Amazon is flowing into the Atlantic. Usually they are considered to be fully marine. Okay, next slide, please. So the group that I really want to introduce you to and talk about are the larger benthic foraminifera. So it's a morphologically diverse group. So, and the diagram here illustrates that there are different wall structures, which you can actually see, and the wall structure is actually one of the ways of identifying the type of foraminifera that you've got. And so that's really key in sort of any stratigraphical work that you might be working on. They can have different morpho shapes. So they can be discoid, they can be ovate, they can be fusiform, in other words, long cigar-shaped things. And what I've shown here on the little diagram on the right is that they're not all having a calcareous wall. Some of them can be agglutinated. In other words, that's the forams which stick grains of sand onto them. They can also inhabit different sort of habitats. So usually we are saying they are restricted to the shallow shelf, but not all. So there's a huge abundance and diversity, and high evolutionary rates make larger benthics useful as a biostratigraphic tool. Okay, next slide, please. So I just want to introduce you to this gentleman, William Carpenter. So William Carpenter wrote this superb book called The Microscope and Its Revelations. And he also illustrated some of the foraminifera. If we go on to the next slide, please. that were found on the Challenger, HMS Challenger expedition in 1872 and 1876. And I've just got an illustration of one here, which you can see is quite a large foraminifera. But this is actually one called Discospirina italica. It's actually a deep sea larger benthic foraminifera. So it's a bit of a contradiction in terms you wouldn't really expect to find this one sort of, or if you found it, you might think, oh, it's actually from a shallow water environment. This one's not. It's actually from a very deep environment, over 3,000 meters deep. And I was very fortunate, and along with Martin, we worked on this form about 10, 15 years ago, when we actually had access to some of the Challenger collection. Okay, next slide, please. So I'll briefly go through this. This is my sort of modern analog in relation to some of the larger benthic foraminifera, and it's an area of at the southern end of the peninsula of the Florida Panhandle. It's Florida Bay, and this is a sat image here. You can see it's got an area of over 1,500 square kilometers. And if we go on to the next slide, please. We'll see that it's quite an extensive area, extending from Cape Sable over on the left-hand side, over to Key Largo, which is on the right-hand side behind the barrier islands. This concentric layer of islands runs down there, and it creates, if we go on to the next slide, so it creates Florida Bay, which, although it might appear to be a large marine expanse, I'm showing you here Commander Ed Fowler's sport fishing map, which I quite enjoy looking at, because all the pink areas on here are water depths of less than, 15 inches. So it's incredibly shallow, and you can actually walk for miles over, within Florida Bay. But the blue areas between the pink areas are often known as the lakes, which are occurring between them. But there are larger benthic foraminifera occurring on both sides of the mud mounds in there, because this is a carbonate mud mound area. And it's quite an unusual sort of environment. So if we go on to the next slide, please, I'll show you some of the forms, most common forms that we found there. So there was two that I was particularly studying in this area. There's Androcina lucasi, which had not been discovered in Florida Bay until we started work out there. And then the dominant species is this one, Archaeus angulatus. That's a very recent specimen there, stained red to show that it was alive at the time of collecting. The green hue to it is because of the endosymbionts, which are within the test. And the thalassia-covered mud mounds on the bottom right-hand side are showing you just how shallow it can be. That's not exposed land you're seeing there. It's actually a thalassia meadow of seagrass. So if we go on to the next slide, please. I'll just take you through. So I actually examined a transect through the keys, and then when we plotted the stable isotopes of the foraminifera, we found that each of the particular environments were slightly offset from one another. Again, that's probably, self-evident now, but at the time when we were doing this work, no one had ever done anything like this before, and no one had really realized that there was this subtle change, particularly in the delta 13 of the carbonate. You can see that the oxygen stays all very much the same. There's not much of a range there, just about a couple of parts, but actually the carbon is quite significant, going from at the south, we've got what is EK, that's Eagle Key. And then as we progressively go along the transect to the open ocean. The OPR is the outer patch reefs. And we sort of studied the three main very large forms that we find there, Androcena, Archaeus, and Cyclobiculina. So it's quite interesting, really, that yes, you can see this obviously in Holocene material. We know we're not going to be able to detect this in, at least not at the moment, in a geologically older samples. And if we just go on to the next slide, please. I think I might just, yeah, no, I'll just ignore this one. Go on to the next one, please. Thanks. Okay, so now we've seen how useful some larger benthics are. Let's have a look at what we were doing in the closure of the Tethys Ocean. So there are a number of ways of dating this, and this is something that, you know, I sat down with Mike and we were talking about this. There's obviously the indirect methods of dating, and Mike talked a lot about this a couple of weeks ago. And they will obviously give you absolute ages. But when we were looking in the Indus Suture Zone, Mike said, well, we've obviously, you know, this timing done from the ultra high pressure metamorphism, and also post-collision molasse sediments coming in. People have been using that. But Mike said, no, what we want is we want a direct way of doing this. And the best way to actually approach this and do this is to actually look at the youngest marine sediments that we can find within the suture zone. So if we go on to the next slide, please. Okay, so Mike had students working out there at the time, and I accompanied one of them out there, Richard Caulfield, and we were looking. He was working on the Spontang ophiolite and the emplacement of that, but rimming that ophiolite sequence are carbonate sediments. So that was going to be the area we were going to sort of examine and collect samples from. So the next slide, please. Which is just a brief reminder to show you that actually we were looking at sediments which were going to occur in this part of the carbonate sequence. In other words, a very shallow end of things, which, yeah, that's exactly what you'd expect. Shallow end when all the marine sediments are being compressed together. Okay, next slide, please. Okay, so in order to actually establish what, you know, a useful tool for this, that's essentially what I was looking for. I spent a long time trying to work out how we were going to use the larger benthic assemblages, because they don't really evolve in much the same way as planktonic foraminifera. They're usually assemblages, mixed assemblages, as we'll see, of larger benthics, which you see both in thin section and in hand specimen. But what was particularly useful and what came up was that I found that there'd been this work to establish what they call SBZs, shallow benthic zones. And this work had been done by Sarah Keel et al. In the late 1990s, 1998. And this provides us with a tool whereby the shallow benthic zones can then be correlated with both the planktonic zonation schemes and the nanoplanktonic zonation schemes that are out there. And if you can tie them in, then you've got a very, very accurate tool to actually use on your rocks which are containing a larger benthic assemblage. So the initial work had been done in alpine terrains. And we thought, well, I thought, yeah, I wonder if I can apply this to what we've actually got in India. So if we go on to the next slide, please. So we examined 4 sections in great detail, and here they are outlined in red. of which there are also 2 others which we looked at, which had already been previously published on. But they're a fair distance away from the actual Indus suture zone. So we had these 4 sections plus samples from right in the middle of the Indus suture zone itself. If we go on to the next slide, please, just to give you some idea of the actual terrain. Again, you saw a lot of images like this. Yeah, next one, please. Yeah, you saw a lot of images like this from Mike's talk last week. Spontaneous ophiolite in the middle there, these huge valleys either side of it, the passes, and then most of this area, or a lot of the larger peaks are actually capped with tertiary sediments. There's obviously a lot of good sections that you can actually analyze and look at as well. If we go to the next slide, please. So here we've got the Paleocene, Eocene sediments capping some of the ophiolite sequence. This is at Singi Kangri in the Spong Valley, a very, very impressive mountain. We did not climb up this, but we certainly got representative samples from the float that was around there as well. And it's usually the float samples which are absolutely packed with foraminifera and larger benthics at that. Some of the sections we looked at, they're a little bit more difficult to actually see, but it was you know, it's rugged terrain. Again, you know, it's something that you're all well aware of. If we go on to the next slide, please. And yeah, I'm sorry about this. I have got some other scanned images. In fact, I've got a better imaging system now, and unfortunately, I just couldn't upload the images into this particular PowerPoint. But here we are in the Zanskar River Gorge in the Indus suture zone, and we've got a typical slide sort of image here, which is showing you how deformed some of these benthic foraminifera are. But it also illustrates quite nicely the diversity of the assemblage that we've got in there. So you can see there's both nummulites there down to the bottom right corner. There's alveolinids in there, which are the ones which look as though they are sort of little black and white lines. And then there's things like Asolina in there as well, which is often considered quite a, has features which are considered sort of primitive to some of the nummulites, but you get all 3 of these types occurring within the same rock type. So the alveolines are actually a type of miliolid. The nummulites are rotalids along with the asolines as well. So 2 different sort of shell or test structures that we've got there. So sometimes some of these forams have been heavily altered. Some of them have been infilled, and I think I've got some illustrations of some of them now coming up. So if we go on to the next slide, I'll just show you, this is our Indus suture zone sketch section. And again, we've got the sort of some of the forams that we found in both the nummulitic limestone and the Sunda formation there. And yes, I do apologize. I have now got better quality images of samples from here, but you can actually, you know, easily see that there's a lot of deformation with some of the forams there, which does make for a little bit of difficulty in trying to identify them. You can usually get them down to generic level quite easy, and then you're looking for other indicators that may provide you with something on what the species might be, but it is quite difficult to actually get all of them down to specific level. but there's usually enough to go at that you can then assign that particular rock formation to one of the shallow benthic zones which occur there. If we go on to the next slide, please. Sorry about that. Right, so I've just got some images here of some of the typical foram assemblages where we can find. I've got discocyclina there on the top left. I think then the next one is all the little black blobs in there, alveolines, and then we've got some nummulites, and the one which is in the left-hand side in the center, you can see there's a nummulite against an alveoline there, and there's been some sort of deformation of the test. Obviously, this has been heavily affected when there's been sort of compression and some sort of slight shearing in the rock. These things, because they're sort of calcite, calcite is a very mobile mineral, so they're really subject to an awful lot of alteration. And then there's some nice discocyclinids in the bottom there as well. I see another alveolines things. Okay, next slide, please. So now we come on to some of the sections that we looked at. This is one marling, and we've got a range of different forams occurring up here, which allowed us to sort of, attribute this to a certain area, and of course pick out some of the smaller benthics that were occurring there as well. I think we've got Morosa Vela in here as well. Next slide, please. And then the same at the Singi-Chu section as well as we're going up the sequence. So it's becoming increasingly shallower as we're going up to our mixed nummulites and discocyclinids at the top of this sequence. And then there's quite there's often sort of huge chunks of the sections which might either be missing or just completely extended. Like the top of this section at Singi-Chu was well over 400 meters, I think. It was a very, very big section, but just terminated with a sharp unconformity at the very top. Next slide, please. Gongma section, again, exactly the same, where we appear in this section to have some which look like some of the slightly older or more primitive types. And I'd often wondered why it is that these, you appear to have some primitive types in here. And sometimes you don't see the example that is the most primitive at the bottom of the sequence, but it might be sort of halfway up. So what I suspect is happening, that these things are actually coexisting together. There is a lot of this now recognized with sort of evolutionary trends. It doesn't just go from one type of foram to another. There's actually coexistence for some time of these different types. And I think with the larger benthics, unlike the planktonics, this is what you see with them. If we go on to the next slide, please. Yeah, Kanji section again, heavily deformed there, and particularly in the limestones at the top, you can see there's some breaks in the sedimentation in there as well. If we then go on to the next slide, please. So we took all of this information and we put it together. Yeah, next one. Right, and these are the our sections that we put together and then tried to correlate between the two of them, including some which had already been examined by Richard in a previous field season, and some which we'd taken from the published literature that was out there as well. And again, what this shows is it's typical of of a carbonate sequence where you get a lot of pinching out of the of the lithologies as you're going sort of east, west, north, south across them. This is very typical of nearly every carbonate environment that you tend to study, and I've certainly seen it here in Oxford when I've been looking at Jurassic sediments around, in this part of the world. It's very difficult to actually do long correlations of the rocks. We're fortunate here in, say, the Jurassic, you've got obviously Ammonite zonations to work with. We don't have that obviously in the Tertiary, but yeah, the larger benthics were sort of holding their own with how we could sort of put together what we might find there. If we go on to, the next slide. Oh, I think I'm going to miss that one out. Yeah, we did some crude isotope work there. About the only thing we could really pick out in here was the Paleocene-Eocene boundary, which shows up quite nicely, certainly in the Kasauli limestone. But yeah, it's the resolution is not good. Next slide, please. So what I managed to do is looking at our assemblages, but was to sort of attribute them to where we might actually find them on the shelf. And so this was beginning to give us our sort of story into where these particular assemblages would occur. So the alveolines and miliolids are obviously to the right-hand side in very, very shallow water. We then go to some nummulites and orbitalites and in sort of the shallower parts of the shelf. And then as we go in slightly off the shelf into the shelf slope and then into the deeper basins, we're going through our acyline dominated sequences down there. So whether or not, again, this is some sort of expression in where the primitive forms which are occurring sort of to the left, whether or not they're being forced out of the shallower environments because the others are just more adaptable to it. Perhaps they have more symbionts in them and can reproduce better. I don't know. And then, of course, at the deepest part, we've got our planktonic assemblages. So next slide, please. So here I've just got, again, some very nice images of some of the assemblages that I've got, that we've come across. The Acyllina discocyclina, one of the more ancient assemblages in the top there, then the nummulites and orbitalites, shallow water, and probably the shallowest water here, the alveolines and the nummulites mixed together. But it's not uncommon to find, all three types within the same slide as well, same thin section when you're examining it. Now, if we go on to the next slide, please, and this is really this is really us putting together our integrated chrono and biostratigraphic stratigraphy with it. So we've actually got the shallow benthic zones now added into what was our nanoplanktic zones and our planktonic zones. As I say, we were the first people to sort of pull this together and demonstrate that this could be applied even in this sort of complex terrain in Zanskar. But what we did get is this very clearly defined break in the sedimentation, and that we could actually put a date on as well. Next slide, please. So again, this is, I'm not really going to spend too long talking about this. Mike went through this very well a couple of weeks ago and spent a lot longer on it than I would, but this was the model that really Mike is sort of responsible for, and we've just been, or I've just been sort of trying to provide evidence for where the tertiaries could fit into this and how we can put this sort of together. Next slide, please. And then, of course, we did just try and sort of put this into a more regional context as well. And I guess it would be fair to say that it's this that, you know, Mike has been having his students work on for the last, you know, 20 plus years. You know, it's been, you know, for him, it's been a labor of love, I think, in sorting this out. But always, everything has sort of pointed to the same sort of mechanism and the same sort of timing for a lot of these events. Next slide, please. Okay, so now we just come to some brief conclusions, which were all expanded upon in the 2008 paper. So the larger benthic foraminifera assemblages provide this excellent tool for the control of the shallow water carbonate facies and the biostratigraphic sort of information and the paleoenvironmental reconstruction that we can apply to it. We had a minimum age of closure and the start of collision was provided by these final marine sediments, which we put down into the P8 or the SBZ10, and the age for that was 50.5 million years. So the maximum age of initiation, 56.5 to 54.9, with the ending, marked the ending of the continuous marine sedimentation, certainly in the Tethys Indus suture zone. And then Mike's sort of major conclusions and major phase of southward thrusting of the oceanic rocks, the ophiolites, etc., onto the northern passive margin occurred in the late Cretaceous in the Ladakh area. And the Indus molasse group, continental clastics, were deposited in this elongate basin with a similar stratigraphy and age and structure along the strike, which extends for thousands of miles, you know, along Ladakh into southern Tibet. So that was basically our work. So if we go on to the next slide, please, which is my last one. So I just need to acknowledge absolutely everyone who we've worked with. Clearly, Mike has been inspirational and the driving force behind all this. We had two Richard Caulfields who worked on this project. The I Caulfield was Mike's student, and the M Caulfield assisted us with a lot of the stable isotope work and the understanding there. Then my two guys who sort of supervised a lot of my work, Martin and Dan Bezents, who's carbonate petrologist out at Royal Holloway College. We got various funding supports, as you do, and I got additional funding from the Royal Microscopical Society as well for it. And that, ladies and gentlemen, is it. Thank you very much. I apologize for the technical problems. I hope they weren't just from my end, and I hope it hasn't spoiled it too much, but it has just been a bit of a rush through it now. But thank you very much for your attention. And of course, I'll answer any questions that anyone's got or any comments that you've got on it. That will also be interesting. Thanks very much.
Yeah,
Thank
those
you,
who want to
Professor
ask
Singh.
any questions, Dr. Singh, you kindly coordinate, and any questions that are there, kindly you may ask from Dr.
Thank
Green.
you, Professor, for a very interesting talk.
Thank you.
Really, I can understand the difficulty with which you have worked, especially working of zonation through benthics is a real tough job. And I really appreciate that. I think the knowledge available from the alpine area has been applied to the Indus suture zone. and that too bringing out larger foraminifera from ophiolites of Indo-Suture zone is a real tough job, and it's very interesting. I never thought that somebody has worked so much in detail. It's very impressive. Thank you very much for presenting this talk. And this talk is very relevant to this Tethys Museum, which Dr. Ritesh Arya has taken to make a Tethys Museum. Especially this talk is very relevant to that. And we will have to concentrate on this work and refine it further or understand it more.
Yeah.
So, thank you very much.
Yeah.
So there's not much question from my side, but I request my other colleagues to come up with some questions.
I should say also I've just recently attended a talk where someone was making the case for extending or recognizing the shallow benthic zones in the Americas. And this is something which I thought was quite interesting. You know, no one's ever done this before, because we've always thought that most of the larger benthics which have migrated certainly into the southern England, which are the nummulites, you know, never made this transition across into the North American basins. But there are larger benthics over there, particularly the soratoids and the like. So it will be interesting to see how they get on with establishing their shallow benthic zonation scheme, and whether or not they can actually tie it into the one which has been successfully recognized and used in both you know, Europe and the Alpine terrains, and now we've extended it down into India and beyond. So I'm going to do a lot of reading around that. But yeah, thanks. So,
What were the deepest benthics you got in this area?
Pardon me, sorry?
What were the deepest benthics you got in the
the deepest ones? Oh, they're probably the discocyclines. They do contain or they're meant to contain endosymbionts, so they must still be within the photic zone. So probably no more than, you know, 80 to 100 meters, probably shallower than that, but certainly no more than that. They've got to be within the photic zone.
Oh yes, yeah. Beyond 80 to 100 meter, it looks quite difficult and not possible. I mean, deeper water may not have occurred in that area. Thank you.
Yeah, thanks.
Yeah, before we proceed with other things, just now I got a call from Dr. Arya, and he was apologizing that he could not make himself available for today's session. Especially Dr. Green, he was referring to you that kindly apologize on his behalf. So that's what I'm doing. And actually, he's in some such area where internet connectivity is not there in Leh. So he said that that's why I'm not being able to attend. So kindly, kind apologies for today. So he'll definitely be available, and he'll talk to you as soon as he's in some area where he can talk to you.
That's it.
Yes.
That's okay.
Thank you very much. Any other questions that we have, and anything you want to ask from Dr. Green, since such a wonderful man is with us, who has lots and lots of knowledge about the nascent fields, I would say, because not many people have worked as much as Dr. Green has worked. So anybody who has anything to ask, you may, please. Most of the people are silent. Dr. Singh, if you want to continue with the discussions.
No, it's fine. The talk was crystal clear, and I could follow him very well. Thank you very much. Thanks for such a exhilarating talk, and we'll definitely try to work on these lines as Tethys Museum comes up. Thank you, Professor. Thank you very much.
That's all right. Well, thank you for inviting me as well.
Thank you, Professor Mike Searle, also to be present during this talk. I met him some 20 years back in Sikkim, if he remembers me.
Thanks a lot to all
Professor
those who
Mike
were
can add
today.
something.
Mike, you're on mute.
Yeah, thank you
Of
very
course,
much.
old memories
Dr.
are
Singh.
golden memories. Yeah,
Yeah.
Dr. Singh. That's there. So thanks a lot, Dr. Owen Green, for being here today and for delivering a wonderful talk. And thanks to all my dear friends who are there. Amodini, special thanks to you for coordinating with us today. Dr. Jigmohan Singh, thanks a lot for being here, for coordinating the whole session. And Dr. Mike Searle, Godavari, James Peters, and others. Theophilus is also there. So all those people who are there who made themselves available for today's talk, thanks a lot to all of them. And we hope that in future sessions also you will be there. You will attend those. On 22nd of every month, we hold these talks. And I hope that on next 22nd, that is 22nd of August at 7 p.m., IST I'm talking about, Indian Standard Time, kindly make yourself available for the talks. Thanks a lot, Dr. Singh. Thanks a lot, Dr. Owen Green. Thanks a lot, Mr. Searle, for being here. Amodini, you may kindly now close the talk. So thank you very much.
Okay, thank you very much, Krishnan. Very nice talk, Owen. Well done.
Thanks.
Okay, bye-bye.
Yeah, take care. Okay. Bye, everyone.
Thanks a lot, sir. Bye.